Satisfying videos. You've seen them, I've seen them, I really like them. Perfect fit, perfect cut. Soap cutting videos. Okay, I don't quite get those, but there is a lot of them, so I guess people do like them. But what makes a video satisfying? What scratches your brain so much when you see one of those? Today I'll try to find it out and hopefully make a satisfying animation of my own. After a somewhat thorough investigation through Reddit and Instagram, I found 4 main types of satisfying videos. First is cleaning. It's when something messy or dirty gets progressively cleaner, and usually you can see a sharp border between clean and dirty parts. Perfect fit. When something slides into place perfectly aligned and you just know that it belongs there. Rolling motion. Things like marbles following the track. It can be really satisfying to see them make those sharp turns at high speeds and never go out. Cutting or other forms of reshaping. When a sharp knife goes through the object and leaves a perfect slice and reveals even more perfect surface inside of it, it's really satisfying. Of course, those are not all of the categories, and they are not set in stone. For example, cutting can be a lot like cleaning. When we remove outer shell of the object and we reveal more perfect insides, it's very similar to cleaning it. There is another factor to satisfying videos. Tell me if you recognize it from this clip. Probably as important, if not more important than the visual part, is sound. Sound will connect you to the video more, allowing you to not only experience the video with your eyes, but also with your ears. At first it may feel like a minor detail for the video, but there are the whole channels dedicated to making satisfying sounds. And now that we've gathered all the information, time for the toughest part, coming up with the idea. I scrolled the internet looking for inspiration, but couldn't find anything that would click with me. But then I went to the store and found something. Yes, this one might work. So, let's use it as a base of making satisfying animation in Blender. First, I modeled the switch. There are not gonna be lamps or anything, just the switch. Really quick, I made the 3D model and set up the base for the material. I want the red part to be transparent plastic and light up when the switch is on. Then I modeled those line and circle symbols, cause I didn't wanna bother with texturing them. So I just made thin geometry with shrink wrap modifier and parented it to the switch itself. That way it looks like it's painted on, but it's not. Here I'm just playing around with the preview, trying to find what looks good. I just set up instances to preview how it's gonna look if I put the switches in a grid. I feel like there is not enough breathing room between the red parts, so make the base bigger to increase the distance between the switches. Now, after I did that, I would have to manually move those copies around to fit together. To avoid that, I set up this grid in geometry nodes. It allows to input the amount of rows and columns, and the geometry nodes will automatically create the grid of points perfect distance apart from each other, so that when we instance collection with our switch copies, they will fit perfectly together. I had some trouble with materials here, used brighter HDRI, and it looks a lot better. Now I'm struggling with geometry nodes. Don't worry, I will explain how everything works in just a little bit. When you are just making something in geometry nodes on the fly, there is a lot of going back and forth. And after some adjustments to the materials and lighting, this is what we have right now. I will extend the animation and add sound at the end of the video. You can see that they will turn on randomly and then turn off in a moving line. Now for the main part. It may look like a lot at first glance, but there are just 3 main parts and 2 of them are super simple. This one is a little more difficult, but there are not so many nodes. For the grid that automatically distributes the switches. Object info node with selected object base goes into bounding box node. Subtract min from max, and now this output has information of how big the object we selected is. Separate XYZ. X and Y go into math nodes that go into grid node, like you see in the video. With all of that, the grid will be automatically adjusting to the size of the object that we selected, and those integer values determine how many rows and columns we'll have there. Mesh to points, faces. This will put a point in the middle of each face of the grid. Now for the tough part. We need to make them flip gradually. We'll make them flip from fully off to fully on in 4 frames. So, how will that work? Basically, when we input the value between 0 and 1, it will make the switch flip between fully off and fully on, but for each light switch individually. First, noise texture, then map range to make it more contrasty. Because by default there are not enough values that are close to 0 and 1. Basically the values start at 0.3 and end at 0.7. That greater than node gives us random selection that is growing until every point is selected. And then we save it into the attribute I called FL, for flip. We save those values into the attribute by doing the following. Name the attribute, FL, add, and add what we just calculated, and then connect it into store named attribute FL. That will save those values as a variable FL for each individual point, so that we can access the data later. If we preview it, we see which points have been triggered to flip and which one haven't yet. White was triggered, black wasn't triggered yet. But if we just connect it to control the rotation, they will just flip instantly, and we need to make it gradual. But next is progress attribute. It's a lot like FL attribute, but when the point is triggered to flip, it changes its value gradually. You can see that we save that attribute the same way as before. Named attribute, progress, add. Don't forget that check mark. It will make all of the values that are above 1 just set to 1. And connect that math node into store named attribute progress node. And then we just need to calculate what we need to add to make that value grow gradually. 0.25 multiplied by FL. That will add 0.25 each frame to the progress value of all the points that were triggered to flip in FL attribute. And then there is this animated math node set to multiply, and it multiplies by 1 on all frames before 157, and starting at 158 it multiplies by 0. That will allow us to flip the switches back off later. If we bake what we have now, the switches will flip on and that's it. Now let's figure out how to turn them off. At the core of it is a position node, separate XYZ. If we preview the X output, we'll see that the points that are positioned above 0 on X-axis are bright, and below 0 are dark. And then we have that animated greater than node. I set it to animate from greater than 24, then it goes down until all of the points on the screen are covered. Same setup. The greater than node is multiplied by 0.25 and then subtracted from the progress attribute. And that is connected to the next store named attribute progress node, basically overwriting the previous one. But we only do it after the previous one has done its job. And here we can see that the values are gradually changing. Now, let's actually use the data that we got to flip the switches. Take the output of simulation zone and connect it to instance on points node. Collection info with the button collection goes into instance. Button collection has just the button mesh and the separate objects that fake painted symbols on the button. Now the data that we have is between 0 and 1, and it tells us the progression of flipping each switch, where 0 means that animation hasn't started yet and 1 means that animation already ended. In our case we need to rotate the buttons between 11 degrees and negative 11 degrees. Make sure that your map range node looks like this. Notice that I have it from min 1 and from max 0. That basically inverts the values. Then convert it to radians and connect it to X input of combine XYZ node. That will rotate the button on X axis. Then take the output from all the way back here and connect it to another instance on points node. There, collection info, and pick the collection where you keep the base of your light switch. Then join geometry, and now we have almost everything. Now we go to the material of the switch, and this is how it looks. The main point of interest here is this attribute node, and it has to be in instancer mode. And what it does is take the information from the geometry nodes and put it into the material nodes, allowing us to access the information of the flip progression. Here I set it to light up when the progress is bigger than 0.76, which is gonna light it up only when the switch is fully flipped. Now, this looks great, but it's missing sound. So I just recorded a bunch of clicks and picked the one that I like the most. Then I opened the video editor in Blender and manually added the copy of the click sound for every time a light switch flips. If you need to move the sound by less than 1 frame, you can do it here. And also you can add modifiers to them to make them sound not exactly the same. And after everything, this is what we have. I did modify animation a bit, adding a section where we are zoomed in on one switch. But I just can't explain how it works in this video. You can try making it yourself. Hint: it involves shape keys and a bit of manual scaling to make the grid less dense. If you make something, tag me on Instagram, I would love to see what you make.